And welcome back. It is Coffee Break with Microchip, where we talk about trending topics and ideas of interest, all in the time it takes you to drink a cup of coffee. I am your host, Ross Ayat, and I hope everybody has their beverage of choice prepared. As we discussed last week, it doesn't have to be coffee. I am contractually obligated to drink coffee, but you can drink what you want. But I hope it's ready. It's ready to go. Today's, in fact, I'm going to have a little sip and then we'll get started. So today's topic is human-machine interfaces, why they're important, what makes a good one, and most importantly, how Microchip can help you implement that in your design. Joining me today in studio, and it's nice to be actually in studio for a change, and not talking to somebody, on the cold screen sitting across the studio. I have Kurt Parker. Kurt is a product marketing manager in our 32-bit business. Welcome, Kurt.
Thank you so much, Ross. I'm so happy to be here in studio. Thank you. Appreciate it. I've got my coffee as well.
Got your coffee. All right. You're free to drink what you want. I got to drink coffee. So
all right.
All right. Well, before we dive in, let us go to the man in the booth, my partner in crime, Austin. Austin, if you can inform people on how they can participate today, that'd be great.
Absolutely. Thank you so much for the introduction, Ross. Good morning, Kurt. Looking forward to touching on some trending topics with you two this morning. We are currently broadcasting live on LinkedIn, Facebook, and YouTube. We have our subject matter experts standing by in the chat to field our audience questions. If our audience prefers to send their questions in via email, they can do so at livestream@microchip.com. Once again, that's livestream@microchip.com. Also, make sure to like our presentation here today and subscribe to our YouTube channel as well as our LinkedIn to stay up to date on all things Microchip and Coffee Break. Back to you, Ross.
Thank you very much. So, Kurt, human-machine interface. We interact with so many machines every day, whether we know it or not. Vending machines and cars and thermostats and all. And for the most part, those interactions go unremarked. We're so used to dealing with them. The times that they don't are when they're either really, really bad, okay, and we get frustrated by it, or they're really, really good, and you look at it and say, "Wow, this is a cool interface." So, why don't you talk us a little bit through why that interface is so important, and then we'll talk about how we might help some people implement theirs.
Thanks, Ross. So, good HMI, human-machine interface, good interfaces. It's kind of like oxygen, right? It only really, really matters, or it's only really apparent if it's not there. So it's kind of like this. You have the interface that you're making for your device, and that is what you're basically using to communicate to and from your machine, to and from your user. If that is developed, if it's well developed, if it's intuitive and easy to use, has all the data that's needed, helps that user do what they need to do efficiently, and perhaps with some enjoyment as well, that user is going to remember that experience. They're going to remember that experience, and the next time they have to do what they're doing, whatever it is they're doing with your machine, they're going to want to look for your machine and not one of your competitors. So now what is happening is that solid HMI is creating a preference. That preference is drawing customers back. It's helping them feel good about it. It's helping them feel okay about spending money in whatever ways your company generates revenue. That revenue generation is profit for your company. So now there's a bright straight line between the HMI that you're developing and the quality of it and the amount of money your device is making for your company.
And the negative is also true, right? I mean, if it's really bad, people are going to avoid you like the plague.
Absolutely.
And how many times have we said, "Oh, I'm not going to do that," simply because it's too hard to figure out.
You find another way around it, another solution, and you completely avoid that bad experience, and no money gets spent in your revenue streams for your company, and that is not a good situation.
So, what dimensions are there in human-machine interface? So, what are the elements that people should be looking at or considering?
So developers should consider three main elements when they're developing their human-machine interface. There's tactile or touch, there's visual or graphics, and then there's also audible or sound. What we're going to talk about today, the first two, we're going to talk about touch and we're going to talk about graphics, not so much about sound.
Okay.
But those are two extremely important aspects in the way that you present your solution to your user and help them get done what they need to get done.
All right. Well, let's start with touch, and maybe you can walk us through the applications that you typically see that, and what are some of the considerations that you want to look at?
Absolutely. So Microchip's been a leader in touch since 1999. We've got many different solutions in a variety of applications. Some of these you can see here. Automotive, both inside and outside, anything from unlocking your car to starting it to adjusting the temperature and whether it's hot or cold within it, the environmental controls. Your headsets, your audio devices, a lot of that revolves around touch now, especially if it's up around your head and you don't have a visual feel for it, then you're gonna wanna be able to just touch on something up there. We handle those things. Many of the appliances and white goods, if it's in your kitchen, if it's in your clothes washing area, your washers, your dryers, dishwashers, things like that, refrigerators, they all have touch components to them. And it's generally whenever you're looking for your user to provide input to the machine, because that is the one-way direction of information for touch. Touch is your user giving information to that machine so that machine can respond accordingly.
And what you're talking about here is primarily touch, sliders. There's more, right?
There's lots of aspects. Yeah, that's right. There's lots of aspects of touch. So we do 1D. So some of us old timers, we want buttons. We want forward and back, right? Yeah. But there's also sliders and wheels, things that approximate physical interactions that we're looking for. The physical buttons and sliders. We can do that on screens, but there's also much more. There's now 2D with multi-touch. So there's pinch and zoom. If you can do that with your fingers, you can now do swipes, back and forth and things like that. And then we've also added 3D, which is gesture recognition. So, swipes are one thing, but what if I can make a check mark and it recognizes that as a check mark? Or I can make a letter on the screen and it recognizes that as the letter and takes an action because it's a specific letter. We've got that built into our libraries and built into capabilities in our microcontrollers as well.
All right. So that's the touch side. So we've got buttons, sliders, gesture, multi-touch, all of those things that in either separate or in combination create that touch interface. How about the graphics side of it?
So the graphics, at first you may just take a look at it and see, well, as long as it looks pretty, it's terrific, but it goes much deeper than that. You've got to present the information that the user needs in order to be able to do what they want to do. You have to present it in such a way that's easy to read. A lot of times it is going to be graphical in nature, charts and dials and things like that. There's also the aspect that your companies as a developer are going to be looking for in terms of reflecting the brand. And this goes to not only a logo, adding a logo, but getting the typography correct, getting the font correct and the size, relative position of the logo, getting the colors exact, getting any motion that is involved with that, how it matches everything else the company's doing, whether it's on the web, whether it's print, whether it's in commercials or anything like that. All of that gets baked into the graphic solution for your device, your capability, what you're trying to communicate. Again, you're trying to create that preference. Visual is one of those ways that you kind of key that preference so that they don't even have to think about it. They had the great experience and they see your logo and boom, you're ready to go.
Right. So all of this, for someone new to this space or even experienced designers, there's always this concern that these are very complex things to implement, that they're difficult, or they require a great deal of experience and expertise. But what we are going to be talking about today, the IGaT, the integrated graphics and touch package, the discovery board, is an easy way to do that, or an easier way to do that.
It is meant to be an amazing out-of-the-box experience. So the integrated graphics and touch Curiosity Kit is this kit that we've developed so that you can get it right out of the box and see the power, see everything that it can do with both graphics and touch. And by the way, it is also a size down and a cost down implementation of a touch panel as well, which is really important. See, we've got, as I mentioned earlier, we have touch solutions, we have graphics solutions. We have them actually together in one package. But previously you had to have separate chips, separate major chips for both touch and graphics together, implementations like that. And sometimes that's still appropriate. Larger screens, for instance, right? We're talking a small to mid-sized touch screen for the solution, but that's appropriate in a lot of the applications we talked about before. So IGaT, the Integrated Graphics and Touch Curiosity Kit, we've integrated the touch and the graphics within a Cortex-M4 microcontroller, the SAM-E5X, and now you have a very simple design, low cost, much easier to implement, and you also have a smaller size, which now gives you options in terms of your design, your flexibility there, and it's widely available out of the box with everything you need to be able to implement it into your application.
So I know a lot of thought went into the design of the board and in making sure that everything that was needed for the designer is present. Can you talk a little bit about sort of the thinking behind the board, or the spirit or the ethos of what you had in mind as you went through that? Because I think it's important as to our customers and to our clients that we've thought through some of these things for them, so that they can, as you said, right out of the box, they can go and innovate and figure out what they're doing without having to spend hours and hours and hours going through it. So maybe you can talk a little bit about the design philosophy.
Absolutely. So when we did this board, we wanted to make it more than just a demo. We could have just as easily threw some programs on there, some graphics with some touch, showed you how the microcontroller works and said, here you go. But it's much more extensible than that. So when you receive the board, if you order it, when you receive it, it'll have several demos working on it. But then there's also the capability through the availability of serial IOs, general purpose IOs, the CAN FD transceiver we put on there, the additional flash we put on there, and the availability of interfaces for different graphics panels that you can make this look and feel much more like a proof of concept for your application. So now you get it to see the power and capability of what it can do in such a small, low-cost package, but then you can use the board to implement what you have in mind for your particular application and your particular market.
And as always, when we put out hardware, we always try and put out lots of demos and lots of examples and lots of code that people can use to say, oh, that's kind of what I want to do, and I can adapt that. Can you talk a little bit about that?
I'm glad you brought that up, because we put out demos where we think this fits, in terms of the types of applications that our users will want to implement. So you see here on this screen, we've got a couple of cooking demos. One's color and one's a simpler black and white. We've got an automotive environmental control demo on here. There's an audio control demo on here as well. And then there's also a gesture recognition demo with machine learning and AI. And that way, that goes on to what I was talking about before with the recognizing characters, the ability to be able to do that up on top of graphics processing and touch processing. But all of this is developed within Microchip's MPLAB Harmony software framework. And so we're providing you all of the tools and all of the libraries and the demo code itself so that you can begin to work with this straight out of the box. The implementation, that bridge, helping to cross that bridge from demo to proof of concept within your own design was very, very important for us. And so we built from the ground up within Microchip's larger MPLAB ecosystem the capability to have everything you need for all the touch libraries, all the graphics libraries, all the development tools, the designer and the display manager and things like that that go into tying them both together, and just trying to help you focus on the part of the application that you're differentiating yourself with amongst your competitors.
Can you go back to the graphic for just a second? Because I do want to point out that the music choice that they picked for that upper left one of Baby Shark is an inspired choice. It's an inspired choice.
I promise all of you out there that it doesn't actually play the music.
All right.
So
now I'm disappointed.
Oh, no, okay.
Now I'm disappointed. All right. So where can our listeners go to find out more information on this?
So they can go to www.microchip.com/IGaT, IGAT. That stands for Integrated Graphics and Touch. And everything you need to know and how to get and how to use and where all the code resides and all the information you need is right there on that website.
All right. Great. Well, thank you for that quick tour. I'm sure there's these are very complex topics and there's lots and lots of detail there. So do go to the website. I think there's not only information there, but there's links to other touch and graphics and other capabilities. So you can you can go explore the whole ecosystem of what Microchip has to offer.
Yes.
So Austin, now it is time to see if there are questions from our audience.
It is the time, and we certainly do have questions from our audience. The first has come in via email, and it reads, where is the code for all of this complexity coming from?
Oh, great question. So the code for everything that's in here is coming from Microchip's MPLAB Harmony software suite. So our framework, which allows you to develop with our with our 32-bit microcontroller. Sorry, I almost used a little jargon there. All the code you need, all the libraries, the tools that you need from the ground up built into the IGaT are developed from MPLAB Harmony. So you can actually get the demos, you can get the libraries that those demos are based on, all of the plibs and all the low-level code, all that's there, and all the tools to connect everything together are there. Again, we really try to focus this on making sure you can work as little as possible in the low-level code and get to the portion of your application that you differentiate yourself with.
Perfect. Well, thank you, Kurt, and I'm sure we'll have some critical links in the description as well. Another question we got in the chat from PLC Worker is, what are the advantages of the SAM E51 versus the PIC 32MZ-DA? Which one should I choose?
Great question. So the differences here are this. The SAM E5X is going to be a little lower cost, and it's going to be quite power efficient, but it's going to run smaller displays, right? So if you're looking to do little, something sub 3 inches, diagonal, then that's going to be your choice because you're going to get that integrated touch. And you're going to get many of the other mechanisms that come with that Cortex-M4 microcontroller. The PIC 32MZ-DA is really a graphics workhorse. It has an integrated graphics controller, an integrated graphics processor, and it has an optional integrated DDR2 DRAM for large frame buffers. So if you're looking at 5-inch displays to even slightly larger than that, 7-inch displays, you're going to want to choose that device as well. But that's a great question. Thank you for asking.
And that was a great answer. I don't know of anyone else that could have answered it quite as eloquently. So another question here via email is going to be, a user says, my target display would be a different aspect ratio. Will that impact the touch channel count?
Well, it does, but the good news is that you're going to be able to manage all of that within the touch libraries that we provide and within the configurator that we provide. And what's also cool, one of the tools we built in, perhaps for the user out there that had this question, perhaps you in the past when you wanted to use your own display and it maybe had a different aspect ratio or whatnot, there wasn't a driver available for it from the manufacturer, right? We had that happen all the time with our customers. So what we did was we created a tool called the Display Manager. Now you take the data sheet from the display that you're working with and you pop open the Display Manager. You go down the data sheet and you say, okay, you look at the different the different data that is on the data sheet. You put it into the tool and hit button, and the tool not only pops out your driver and puts it in the correct place and connects it to all the different components within your application project, but also takes that driver and duplicates that display and that aspect ratio in the graphics designer. Now, the graphics designer is the tool that you'll be working with the most to actually design your graphics. And it is WYSIWYG. I don't know if you, Ross, if you ever heard the term WYSIWYG.
What you see is what you get.
That's right. What you see is what you get. It's really important for us because we really do fashion the graphics tools to cut down the iteration time between changes in the graphics by up to 90%. And one of the ways we do that is to assure you that with that display, with that aspect ratio that you want plugged into that tool, that when you place a widget or an asset or a text within that display, it's going to appear exactly that way on the glass. And that way you could be in front of a decision maker, you could be in front of one of your evil marketers who says, I want this box moved, this box on here, I want it moved 2 pixels to the left. And used to be you had to go back and schedule another appointment with them a week later and do lots and lots of iterations and move from tool to tool, likely not from the same manufacturer. But in this case, you could do that in front of them in less time than it takes to drink your coffee or to have this live stream. Right?
All right.
Well, we got one more here for you, Kurt, and that's going to be via email as well. It's, do I need to pay a license to use the graphics and touch libraries on the SAM E51 integrated graphics and touch?
Thank you so much for that question, whoever sent that. I appreciate it. No, you do not have to pay a license for the vast majority. There is a caveat. We do have that machine learning capability on there, and it's provided to us by a third party, so more information is going to be on there. You can use the demo for that, but if you want to establish that capability in your application, you have to license that code and that capability with them, and we'll provide you the information and how to reach out to them and to get that license.
Perfect. Thank you so much for taking the time to field our audience questions, Kurt. And that's all that I have today. Back to you, Ross.
All right. Thanks, Austin. So, again, if you have questions that occur to you later, you can always send them to us live stream at microchip.com, and we will get them fanned out to the right people, get them answered, and get an answer back to you. You can also go to the archive of this podcast or this live stream and post them there, and we'll clean them up there and get them off to the people who can answer them for you. So for those of you keeping score at home, this is episode 4 of season 4. If you would like to watch this again, we post it on our website at microchip.com/coffee break. You will find it there. You will find all of the other episodes from all of the other seasons, 20 some odd episodes and counting. So do feel free to go wander around, take a look. There's lots of great content there. You'll also see a schedule of what's upcoming, the episodes that will be broadcast in the coming weeks. So with that, I think it's time to say thank you. Thank you, Kurt. Thanks for being here to provide all
thanks
the detail.
Thanks for having me. This was fun.
Austin, thanks for manning the board.
Thanks, Austin.
The crew here, Sean, Philip, Kurt, David, thank you, everyone.
Appreciate it.
Thanks.
Thank you, guys.
Special thanks to Claudia, who keeps everything rolling, keeps me honest, keeps me on track.
Thank you, Claudia. Yes.
Make sure that I show up where I need to show up.
Yes, definitely.
So thanks for that. 2 weeks from now, our topic will be A to D converters. So we're going to change gears a little bit, go into the analog space. We're going to talk a little bit about selection criteria or decision making on whether you should use an embedded ADC in your microcontroller or a standalone. So look forward to that. I think that is 2 weeks from now. So until then, stay happy, stay healthy, stay curious, and keep on learning, and we will see you next time.